All right, welcome back, 7th math students. So last week we did some tree diagrams, so compound probability, more than one thing that is happening, and then we listed out all total outcomes. Today we're still doing compound probability, and we may use some tree diagrams or other ways to organize the compound events, and then we're going to find probability of the actual two events happening, okay? So I already have two definitions down here. Simple event is just an experiment where there's one outcome, one thing is observed and recorded, such as drawing a card from a deck of cards. If you just draw one card, that is a simple event. Okay, the second that we draw a second card, that's a compound event, and I have both of these definitions written out. A compound event is an experiment in which more than one outcome is observed and recorded. Okay, and then this is just a reminder, we have already talked about this spot here. Remember that finding probability, you're creating a ratio or a fraction of favorable outcomes over total possible outcomes. So I already had all that written out for you to save some time. So let's look at these examples. Jack flips a coin twice. What is the probability that the coin lands on heads both times? So first, is there just one thing happening? If he's flipping the coin twice, well, the twice word is telling us that this is a compound event. So we have the probability of flipping the coin the first time, and then we also have the probability of the second flip. That takes into consideration of the whole probability, okay? So, combinations. We could create a tree diagram. I'm going to show you what Pearson is going to do in this event, or how it organizes it. So for flipping a coin, basically we can get a heads or a tails. Okay, so that's our first coin. Now on the other side of our diagram here, this is our second coin. So our second coin, again, we could have a heads or a tails. And they organize it into a nice little table. So our total possible outcomes, each one, I'm going to create then. So here, heads for the first flip and heads for the second flip. So heads is an outcome. Okay, tails for the first flip, then heads for the second. So tails heads, heads for the first, tails for the second, or the last one, tails. So there are 4 total outcomes. Okay, so the probability it's asking is what is the probability of the coin landing heads both times? Well, heads both times is right here. So we just have one favorable outcome, and that is 1 out of 4. Or we could also say that is 25%. Okay? Let's try the next one. So next one, Alexis rolls a number cube and flips a coin. So again, more than one thing happening. We're rolling a number cube and we're flipping a coin. So this is again a compound example. All of your examples in your Pearson homework will be compound. Okay, so again, let's kind of create a table. So the first thing we're doing is rolling a number cube. So on our number cube, our total or our possible outcomes, we could roll a 1, we could roll a 2, a 3, a 4, a 5, or a 6. So that is our first event that is happening. All right, the second thing then, I'm creating my table, is flipping a coin. So if we flip a coin, well, then on the side here, we could either flip a heads or a tails. And then we can create our full table here. So we could roll a 1, flip a heads, roll a 1, flip a tails, a 2 heads, 2 tails, and so on. 3 heads, 3 tails. So we're listing out and organizing it so that we can see every single possible outcome. 5 heads, 5 tails, 6 heads, oops, and 6 tails. So how many total, whoa, sorry guys, how many total possible outcomes are there then? And sorry, I was trying to keep it organized with colors. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes in this one. So that will be our bottom number in our fraction. Okay, so what are we looking for? Well, we want that she rolls a 2 and flips a tails. So rolls a 2, here's our 2, here's our tails. So here is a 1 favorable outcome, and that would be 1 out of 12. And I don't have the percent of that one off the top of my head. Let's see, 1 divided by 12 for our fraction. And there we go. So 8.3%. The repeating 3 there, and here we can turn it, into a fraction. Remember, guys, if we're changing it to a percent, we're multiplying by 100. So I'm moving that decimal twice. So 8.3333. In your Pearson assignment, it does want you to put it then as a mixed number. So that would be 8 1/3%. Okay, I did your Pearson homework, and there was an example that was a repeating decimal like that and had to be turned into a fraction. Okay, next one. So we are spinning a spinner. Find the probability that you spin on a shaded section that is a factor of 10. Real quick, factors of 10. Remember, factors mean multiply to get to 10. So 1 times 10, those are factors. 2 times 5, 3, 4, and that's all. So there's 4 factors of 10, okay? So let's think about, is this simple or compound? Is there more than one thing happening? All we're doing is trying to find that we spin a shaded section. So we're looking at these shaded sections, and then which one is a factor of 10? Is there more than one thing happening here? We're only doing this once. So this is a simple probability example, okay? If we spin that spinner once, well, there's 8 total numbers on that spinner, so we have 8 total outcomes, okay? And they're all listed there, 1, 2, 3, 4, 5, 6, 7, 8. So numbers 1 through 8, okay? So of those ones that I highlighted here, well, 1 is a factor of 10, 3 is not, 5 is, 7 is not, so we have 2 favorable outcomes, okay? So 2 out of 8, and we always want to simplify, so that simplifies to 1/4. And again, as a percentage, that would be 25%, okay? These last 2 examples get into quite a few total possible outcomes. We have 2 people, Mia and Olivia. They both are rolling a number cube. So 2 people are rolling, so this is a compound example. Next week, we're going to get more into these type of examples. What's the probability that they both roll a 5? We could make a big, long list here and say that Mia rolls a 1 and Olivia rolls a 1. I think that was, yep, those were their names. Olivia rolls a 1, but Mia rolls a 2. Olivia 1, a 3, a 1, a 4, 1, 5, 1, 6, so on. We could continue this for all of them. So let's say Olivia rolls a 1, Mia rolls a 2, Mia rolls a 1, 2, 2, 2, 3. In the end, guys, if we continue this big long list, there are 36 possible outcomes, okay? We're looking, outcomes, let's change that interesting O. Oh my goodness, so total outcomes. Sorry, you can probably hear my child wants a yogurt. He is very upset about it. So, we are looking for both rolling a 5. Well, in this, if we continued this list and did all the 3s, all the 4s, all the 5s, and all the 6s, there would only be one favorable outcome that would have 5, 5 in it. okay? Notice I didn't continue all 36 of those outcomes. So there would be one favorable outcome, and that is out of 36, okay? Next week, I'm going to show you how to find this a different way so that we don't have to list out all 36 outcomes. That takes a lot of time. So I'm going to pause here. I'm not going to finish the notes completely because next week I'll record a video and I will show how to do it a different way so that it's a little easier. But for this week, that's where I'm going to stop. That's what is covered in your Pearson Realize assignment, and you guys should be able to do it from there. All right, thank you guys, and have a wonderful week.